Alright, so this video we are going to continue with the previous part that I stopped just now. Okay, because for the previous video I stopped it halfway because I'm having an online meeting, so I have to stop recording. Okay, so let's continue with example 12, which is continue from the previous video, right? Okay, so in the previous video we actually learned how to use the Poisson distribution in application question. So this is a last example for this part. Okay, so we can have a look here. Okay, so at a certain airfield, planes land at random times at a constant average rate of 1 every 10 minutes. So you again highlight the keyword every 10 minutes. So this is actually the interval given in the question. All right, and then they say 1 every 10 minutes. So the mean is 1 for 10 minutes. Alright, okay, so let's start with the calculation part here. Okay, first, they want you to calculate the probability that exactly 5 planes will land in a period of 1 hour. So they give you the interval for 10 minutes and they want you to calculate the probability for 1 hour. Okay, so this question is not hard. I will let you to try on your own. So the answer should be 0.161. Right, so this is what we have for part 1. Okay, then for part number 2, find the probability that at least 2 planes will land in a period of 16 minutes. So again, you need to change the mean according to the interval given in this question. And after that, you find out the probability. It is not hard also, so I will just leave it for you to get an answer, which is 0.475. Okay, so the main question that I want to discuss is actually this one, part number 3. Alright, so if you're interested, you can actually pause the video first and then you attempt it on your own. After that, only you come back to this video again to see the solution, whether is it correct or not. Okay, so now for this question, I want you to highlight the word given that. So do you feel familiar when you see this word? So it actually involves the concept for probability that we learned in AS level. So when you see the keyword given that means what? They tell you that this is a conditional probability. I hope that you still remember all this. So conditional probability. Alright, so they say given that 5 planes landed in an hour, calculate the conditional probability that 1 plane landed in the first half hour and 4 in the second half hour. Alright, so this question becomes a bit complicated because of the conditional probability. Okay, so no matter how, I will try to write out the question first, the symbol first. They want you to calculate the probability, right? Given that what? So the given that you have to write after the slash. So given that 5 planes landed in an hour, so it should be x equals to 5. Okay, so for this x equals to 5, that means that the number of planes landed in an hour. So the duration is 1 hour. And then after that, what they want to calculate? They want to calculate the conditional probability that 1 plane landed in the first half hour and 4 in the second half hour. So when I write out, I can write out x equals to 1, and then I'm having x equals to 4. Alright. So if I write A out in purple color like this, means that for x equals to 1 and x equals to 4, the duration is a bit different, which is in half an hour. Alright, so can you see the difference for blue and purple color, right? Okay, so for the blue color one, it is in an hour, and then for the purple color one, is for half hour the duration. Alright, so now, so before we continue to get the answer for this one, since we already know that our interval in this question of an hour and also have half an hour, therefore I would like you to write out the mean for these two parts first. So what is the mean here? Okay, so maybe I use dark blue again for 1 hour one. Okay, so what is the lambda for 1 hour? Okay, so just now you're having 10 minutes. 1 for 10 minutes, right? So now you're having 1 hour, which is 60 minutes. So that means you are having 1 multiplied with 6. So the mean is actually 6 for, this one is for 1 hour. Okay, then now for purple color, I want to get the probability, the mean for half an hour. So for half an hour means you multiply it with 3, correct or not? And therefore you should get the mean, which is a 3. So this one, if you want to remind yourself, it is actually for half an hour. Okay, so now let us continue here. When we are having a conditional probability, the formula is what? The bottom part is the probability for x equals to 5. Okay, and the probability on top is actually the probability of x equals to 1 and 4 intersect with x equals to 5. Still remember not? Okay, so what is the formula? Just to recall. So what is the formula for conditional probability? So for conditional probability is when you're having B slash A, what is the formula here? The bottom should be probability of A, right? And then on top we should have A intersect B. Okay, so this is how we write out the formula for conditional probability. So you learned it before, now you need to apply it here. Okay, then let us continue. Okay, so when they said x equals to 5 in 1 hour, it is like your sample space. Okay, so let's say this square or rectangle is actually x equal to 5 in an hour. Alright, so inside the x equal to 5 in an hour, right, you can have a lot of different cases, such as you may have first half an hour is 0, second half an hour is 5. Okay, and you may have first half an hour is 4, is 1, then the second half an hour is 4. And so on. You might have first half an hour is 2, and then the second half an hour is 3. Okay, not only this one, by half an hour, the difference by half an hour, you might also have, maybe they will tell you, oh, the first 15 minutes you have 0, and then for the last 45 minutes you have 5. Okay, so there are many cases here. But of course, you cannot list out all. Alright, so you can have different interval, but as long as the total of the planes landed is equals to 5, that means it belongs to this. In 1 hour, that means it belongs to this rectangle one. Okay, so if you look at our example here, x equals to 1 and x equals to 4 is one of the cases that appear in x equals to 5. So which means when they intersect each other, right? So let's say this one, this is x equals to 1 and also x equals to 4. So x equals to 1 for the first hour, x equals to 4 for the second half an hour, right? So total is 5. And when you intersect it with the rectangle here, you will actually see that the intersection part is only this one. Okay, so from here, you will see that your next step is the probability of x equals to 1 and also x equals to 4 only. Because when it intersects with x equals to 5, you only get this. X equals to 1 and x equals to 4. So divided by x equals to 5. Okay, so this one actually is it needs some common sense from you all, right? To understand. Okay, so how to continue from the previous step. Okay, then let's continue further. Alright, so since now you're having x equals to 1 and also x equals to 4, right? So x equals to 1 is for half an hour. So half an hour means that when you have to calculate the probability, it will become e negative lambda power 1 divided by 1 factorial. And because the x here are independent with each other, right? For Poisson, one of the conditions is the events occur independently. Therefore, you can straight away multiply it with independent, so you multiply each other. So x equals to 4. So for x equals to 4 is negative lambda e power negative lambda e power negative 3, then 3 power 4 divided by 4 factorial. Okay, after that we divide. Divided by what? So divided by the probability of x equals to 5. But again, for this x equals to 5, it is in 1 hour one. So the mean that you are using should be 6. So it will become E negative lambda. So lambda power 5 divided by 5 factorial. Okay, then by just pressing calculator, you should be able to get the answer, which is 0.4. It should be 5 over 32, or you will get 0.156. Alright, so this is what we have for this example. So to me, this is one of the questions that besides applying the Poisson knowledge that you learn in A2, but at the same time, you need to still, recall back the conditional probability that you learn in AS. Okay, and then from the steps, you actually need some common sense to know how to continue to the next step. Alright, so I just drew a very simple graph to show you roughly, okay, how I get the intersection here. Alright, okay, so you can see that you cannot totally forget what have you learned in statistics 1. You still need to apply some of the knowledge in statistics 2. Alright, so that this discussing this question will give you some very brief idea, like how are they going to link AS and A2 together. Alright, like just now, the previous video, we also got one question, right? Maybe the first part by Poisson is Poisson distribution, and the next part they involve binomial. So they actually combine Poisson and binomial together. Right, so all this might happen in the exam style question. Okay, so please take note on this. Right, so I will stop this video here. So that next video, we are going to start with another new subtopic. Alright, so for the next video, we are going to discuss how to change binomial become Poisson. Alright, so we will discuss this in detail in the next video. So that's all for this short video here. Right.